Hartzell Propeller leads the industry in composite blade technology. Our composite blades are lightweight, durable, and engineered for cutting-edge performance. Unlike aluminum or wooden blades, they can be restored to their new dimensions over and over again. They're surprisingly easy to repair. This video demonstrates repairs made to a Kevlar or Kevlar carbon hybrid blade, specifically on damage to the trailing edge foam region of the blade. For purposes of demonstration, the blade shown in this video is the Hartzell N7605K. Before you begin your repair, you can find your specific blade model on a sticker on the cylinder of the propeller. For some earlier composites, that sticker will be on the blade. If the blade model isn't obviously identifiable, just check for it on the inspection sheet that came with your prop. Your specific blade model will be identified by the characters after the slash. Hartzell Technical Representative Kevin Ryan has taught countless classes around the globe about the intricacies of composite propeller repair. Today, he'll teach you.
Hi, before we get started, let's look at some of the materials and tools we're going to need to perform a repair on a Kevlar or a Kevlar carbon hybrid blade. You'll need a coin tapper, a sanding block, and some sandpaper. The repair materials, e-glass, fiberglass. You'll need clean rags, clean lint-free rags. Don't ever use one of these commercially available shop rags. They have oil in them and they'll damage your repair. In this case, we're using cheesecloth. You'll need a marker, Sharpie, a steel straight edge, a piece of 20,000 safety wire, some vacuum bag material, the repair adhesive, a tape measure, scissors, some acid brushes, a grinding or sanding tool like this Dremel or a die grinder, some clamps, C-clamps, some spreader plates, some solvent. This could either be MEK or acetone or denatured alcohol. The appropriate colors of touch-up paint. A DA sander can come in very helpful post-repair. Some tape, and let's not forget your personal safety equipment, dust mask, and a pair of safety glasses.
Before beginning any repair, you'll need to reference the Hartzell Composite Propeller Blade Field Maintenance and Minor Repair Manual. It's more simply identified as Hartzell Manual 170. You'll find Manual 170 on our website. Just type in hartzellprop.com/Manual 170 and the PDF document will download to your computer. Once Manual 170 is open, first click on the chapter entitled Inspection Procedures in the left margin. Under the list of figures, find the link that identifies your prop. In this case, since we have an N7605K blade, we know it's listed as an N-shank blade. Click on Figure 1.3. Here, you'll see a graphic of your blade. In order to properly assess the gouge, we need to determine whether it's on the outboard or inboard region of the blade. You'll see here that distance Z is the length of what is considered the outboard region of the blade. Look at the chart below, and you'll see that for our prop, that distance Z is 18.43 inches on this blade.
So we'll take a quick measurement from the tip, and we'll see that that gouge is somewhere in the neighborhood of 13.5 inches. So it's on the outboard portion of the blade. So we'll use that repair scheme to determine the repairability of this blade.
Now, when you return to the manual, navigate to the chapter called Damage Evaluation. When you click on the title in the left margin, you'll see a list of nearly 36 kinds of blade repair. Our type of damage is considered a gouge or loss of composite material on the outboard region of the blade. In this case, number 21 on the list. Click on the link and you'll see this chart. Locate the model N7605 on the vertical grid and follow it down to the horizontal grid for line 32. You'll see the X where line 21 intersects with the 7605 blade is line 21 limits 2. Again, follow the proper links And you will eventually end up at this table that will tell you whether your damage falls within the airworthy damage limits of the prop. There are two important things to note here. Notice under the limits designation, it says, do not include the paint while measuring the depth of a gouge or loss of composite material. So we need to remove the layers of paint before we measure our gouge. Also, the maximum permitted diameter or equivalent area of a gouge or a loss of material is 500 thousandths of an inch. The maximum permitted length of a gouge or loss of composite material is 2.5 inches long. And the maximum permitted depth of a gouge or loss of materials is 20 thousandths of an inch. So let's determine by these specifications whether our blade is repairable.
So I've got this gouge on the blade, but to determine its depth, I need to remove the paint because I'm interested in what's damaged in the composite material itself, not the paint. Remember, I'm allowed 20 thousandths depth, and I have several thousandths of paint here. So I'm going to remove that paint so I can accurately assess the damage to the composite material itself. Once again, I'm going to use 80 grit sandpaper and a sandpaper block and remove the paint in the damaged area. So now I've removed the paint and I can assess the gouge and the damage to the actual composite material itself. Now, as you may recall from the manual, we're allowed 20 thousandths in depth on a gouge. It can also be 2.5 inches long. Well, we certainly don't have 2.5 inches. We need to determine how deep it is. Because this gouge is so small and so narrow, it can be difficult to get a type of a tool inside the gouge to assess the depth. But every aviation shop has 20 thousandths safety wire. You're allowed 20 thousandths depth of the damage. See if the piece of safety wire will go into the gouge. If the gouge is deeper than the wire, it's deeper than 20 thousandths. But if it's above the gouge, it's not 20 thousandths. You don't know exactly how deep it is, but you know it's less than 20 thousandths in depth. So we just put the wire in there, and this has very, very little depth at all. If it appears that it may be deeper than the wire, you can stick the wire in the gouge and take your steel straight edge and put it on the wire and see if it rocks or if there's a gap between the wire and the blade. If there is, it's not 20 thousandths deep.
You may notice throughout this video that other parts of the propeller blade will be shown in various stages of repair, like this and this. That's because this video was taken over a period of time when we were also creating videos for other blade repairs on two other sections of the blade. Of course, none of this affects the repair that we're focusing on here. It's just a simple note for your reference as we continue through the repair process.
To repair this gouge, what I'm going to do first is I'm going to measure out about 1/2 inch away from the end of the gouge and either side. There we go. What this does is this gives me an idea of how much area I need to bevel out to get to accomplish the repair properly. I'm going to go down to the bottom of this gouge, and then I'm going to remove extra material around it to effect the repair. So I've removed the bottom area of my gouge, and then I worked my way outward, and I could bevel it a little bit more to get it out here. I need to go out just a little bit further. It was difficult to see due to the dust. To perform this repair, take a cloth with some solvent and wipe the area. And as the area dampens, you can see where the low spot is where your original damage was. Then quickly take a piece of vacuum bag material, place it over the spot, circle the low area, and then circle the beveled area. Then you can use this as a template to cut out your repair materials. Cut out your repair materials prior to mixing the adhesive. The adhesive has a fairly short pot life, about an hour, so it's important to cut out your repair materials prior to mixing the adhesive so that you have the maximum amount of time to work with that adhesive. I'm going to use this template now to cut out my repair material. This is E-glass, and it's used to repair the N7605 blade, the carbon Kevlar hybrid blade. So what I'm going to do is, before I cut this template out, the weave of the fabric is important. You want to have your material, when you apply the second piece, at about a 45-degree angle to the previously cut piece. So the easiest way to do this, because this material weave is so fine, I just make some parallel lines with a marker. And then I'll put my template on, and I'll cut out my first piece. So I cut my first piece like this. So my second piece, I'm just going to cut so it's on a bias. Now it's still got a straight line through it, but I just oriented the template so I'd cut the second piece on the 45-degree bias. And I can also make certain that when I attach it to the blade, that center circle is on a different angle than this original piece. And the straight lines will keep me honest. This is the adhesive we're going to use to effect the repairs. The adhesive is mixed by weight. It's 100 parts of part A to 33 parts of part B. Once again, it's mixed by weight. This is a quart kit. This is what we buy at Hartzell that we use for production. There are also smaller quantities of this available commercially. You can get what they call a 50-gram pudding cup. Those parts are already pre-measured. You can just dump the one cup into the other. There's also an Easy Pack. The Easy Pack is 2 packages separated by a plastic separator. You pull the separator apart and you can mix the material in the bag. So if you're going to just do some small repairs, quart kit's probably overkill. Buy some of the pudding cups or the Easy Packs. Before I start this repair is still dusty from the sanding. So I'm going to tack this one off with my alcohol again. Make sure it's clean. Then with my adhesive, I'm going to paint the whole area and some of the area surrounding. I'll take my small repair piece, and I'll put it in there. Notice the direction my line's pointing that I drew when I cut the piece out. And then I'm going to thoroughly saturate that piece. Then I'm going to take my second layer. Notice these lines are horizontal, my other one's at a 45-degree. I'll put that one on that piece. And then once again, I'm going to thoroughly saturate the repair material. I have another piece. This is light fiberglass. You may be able to see this is not the E-glass that I use for the repair material. In this piece, you don't have to be careful about the size you cut it or anything. It just has to be big enough to cover the repair. And I'm just going to lay it on top of the repair. Now the reason for this material is this material fares the repair into the rest of the blade so that when we come to the sanding portion, we'll sand most of this material off and it just blends the repair into the existing surface of the blade. I'm going to take a piece of vacuum bag material and place it over the repair. I'm going to cover the repaired area with a semi-rigid plate. This is actually an auto body filler spreader. And what I like about these is on the camber side of the blade, it's flexible enough that it'll conform to the camber of the blade. Because this is in the center of the blade, it's difficult to reach with a clamp. So I'm just going to tape it in place. Just hold that in place. The adhesive for the repairs have cured. It takes 12 hours at room temperature to cure the adhesive. So now we're going to remove the tape and see how the repairs have come out. That seems like a good repair. We're going to sand off this repaired area here. You'll notice when I start to sand it off that much of this white area will fly off almost immediately. There's no concern about that. As I said when I put it on, this is an almost entirely sacrificial layer that's just put on just to fare the repaired area into the rest of the blade. I'm going to sand this area off with 150 grit sandpaper. You can go a little lighter if you'd like. You don't want to go too heavy, but I'm going to use 150 grit sandpaper to start out, and I'll sand this area, and then we'll check it for soundness. I've removed most of the adhesive and the the fiberglass cloth is on top of the repair. I'm going to finish the sanding by hand because it gives you a little bit more control. Once again, I'm using 150 grit sandpaper. So now that I've sanded off the repair area, I want to make sure that the repair that I have is sound. So I'm going to give it a coin tap inspection. Tap the entire area of the repair. I'm not hearing any difference in tone. So that indicates it's a good repair. As you can see, we've done 2 repairs here. But even if we only did this one or this one, when we went to paint it, aesthetically, it wouldn't look very good to spot paint it. Now, there's nothing that says you can't. You'll still be protecting the blade will still be airworthy. It just won't look very good. So what we've decided to do is we're just going to scuff up the remainder of this blade, and we'll spray the whole side. I'm going to use 400 grit sandpaper, and I'm just going to lightly scuff the area to be painted. I'd suggest if your shop finds that they're doing a lot of this kind of work, your best option might be to go to the local vocational school, find a high school kid that's majoring in auto body repair, and tell them you don't want to work in an auto body shop, you want to work in the wonderful world of aviation. While I'm cleaning the blade, notice that I've masked off the tip stripes, the leading edge of the blade, the de-ice boot or anti-ice boot if they're installed. If the blade doesn't have a de-ice boot or an anti-ice boot installed, it should have some erosion tape installed in this area. And if there's the erosion tape installed, you'll need to mask that as well. So now we're ready to paint. Once again, I'm going to use the touch-up spray paint. You wouldn't necessarily have to use the touch-up spray paint that's in a can. You could use the paint that we specify for the blades when they're new or when they're overhauled. This is paint that's canned up for Hartzell, but there's also a commercial product that's also in a spray can that's available for sale that you could purchase on the internet. All those part numbers are in our manuals. This paint won't look terrific, especially in the areas where I've done the repairs. It's going to take multiple passes. So we'll wait for this to dry. We'll give it another coat, and eventually it should look pretty good. Thanks for watching this video. I hope it's done something to dispel some of the fears you may have had about working on composite bladed propellers. As you can see, the repairs aren't particularly difficult, and with a little bit of practice, you can perform them in your shop. And if you happen to run into trouble, you can always give us a call here at Hartzell or send us an email. Thanks again for watching.
For more information about Hartzell composite propeller repairs, we invite you to contact Hartzell Product Support. Call 800-942-7767 and then option number 3. Or visit us online at hartzellprop.com.